Hi, I'm Don Dawson. Today we're going to drive home some important information on hand and power tool safety.
Most people have injured themselves with a tool at least once in their lives. Unfortunately, tool accidents result in thousands of serious injuries and hundreds of deaths each year, most of which could have been avoided by simply handling tools safely.
There are a lot of different kinds of hand tools, and new types of portable power tools become available every year. Power tools can run on electricity, gasoline, air pressure, hydraulic fluid, even gunpowder.
Depending on what type of tool you are working with, it could have the potential to cause abrasions, lacerations, amputations, puncture wounds, contusions, eye injuries, burns, electric shock, muscle sprains, and broken bones. Using tools can also lead to health problems, such as hearing loss and tinnitus, a constant ringing in the ears, back and neck injuries, repetitive stress disorders of the hands, wrists, and arms, and respiratory problems, including emphysema, chronic bronchitis, and lung cancer. Power tools can be particularly dangerous since they often expose you to multiple hazards at once. For example, when using a circular saw, you could be cut by the blade, struck in the eye by flying wood chips, or shocked by the electric current. Breathing in sawdust may cause respiratory problems, and the noise from the saw can contribute to hearing loss. Non-motorized hand tools don't present the same degree of danger as their powered counterparts. However, since hand tools are driven by your muscles, there is an increased risk of repetitive stress injuries. Whether you use hand or power tools, there are some general safety practices that you should always follow. Keep your tools in good condition. Use the correct tools for the job. Know how to properly operate tools before using them. And always wear personal protective equipment, especially eye protection. Above all else, don't use tools unless your mind is clear and you can stay focused. Being sick or distracted can impair your judgment, especially if you are taking medications. And you should never use tools if you are under the influence of alcohol or illegal drugs.
No matter how safe you try to be, if your tools are in bad shape, you are likely to have an accident. So make sure that you keep them in their carrying cases or storage cabinets to help prevent damage.
If there's an owner's manual, store it with the tool or in a nearby file for easy reference. Always follow the manufacturer's instructions for cleaning and maintenance. Inspect your tools every time you use them. Things to look for include cracked or bent pieces, loose or missing parts, and rust or corrosion. The handles on hand tools take a lot of abuse. Make sure that they aren't loose, cracked, or splintered. You don't want a tool to lose its head and hit someone. Tools that you strike must be in good condition too. For instance, a cold chisel with a mushroomed head could cause eye injuries from pieces of metal flying off each time it's struck. To prevent this, keep the heads on these chisels ground down. Most tool accidents involve cutting tools. Make sure that you sharpen and replace blades often so they cut with minimal effort. If you try to cut something with a dull tool, you are likely to slip and cut yourself instead. Use sheaths or snap-on blade protectors when storing cutting tools. Tools with retractable blades, such as utility knives and planes, should have their blades withdrawn when not in use. Sometimes you may have to improvise to protect your tools and keep them sharp. You can use corks or styrofoam to cover the points on awls and wood chisels. Foam pipe insulation makes an excellent cover for handsaws. And plastic pouches are great for storing small tools. This also protects the people who are picking them up. Circular saws must have self-adjusting guards that protect you from the blade. These guards should immediately snap back in place after you've made a cut. To keep the guards functioning properly, clean sawdust, wood shavings, and dirt off of the hinge. You can also apply an occasional drop of oil, but don't overdo it. Too much oil can attract debris and cause the very problem that you are trying to prevent. Before plugging in a power tool, check its housing to make sure that there are no cracks. Verify that switches are not loose or damaged. And carefully inspect any hoses or power cords to make sure that they are not cracked, frayed, or otherwise damaged. A broken tool of any kind is dangerous. Tag damaged tools as out of order and install lockout devices on them to make sure that they can't be used.
Before using any tool, you need to check your work area for potential hazards.
If the area that you are working in is dimly lit, you should set up portable lights to make it easy to see what you are doing. Make sure that coworkers are at a safe distance from flying debris and other hazards. Cordon off your work area with caution tape if necessary. You can be seriously injured if you trip and fall with a tool in your hand, so keep the floor in your work area neat and clean as well. Tool injuries often occur when workers become distracted. Never bother a coworker who is using a tool. If someone is trying to get your attention while you are working, stop what you are doing before finding out what they want. Never leave tools on top of a ladder or on scaffolding where they can be knocked off.
You need to protect yourself whenever you are using tools. A hard hat can cushion blows to the head. Many jobs require work boots with steel toes. And always wear eye protection.
Ordinary safety glasses are fine for jobs where there is minimal risk of flying debris. But safety goggles offer a better defense and should be worn when using hammers, wire snips, or power saws. Many tools produce ear-splitting sounds, so hearing protection may be required as well. You'll need some level of respiratory protection when sanding, cutting, and grinding. Dust masks do a good job of protecting your lungs from sawdust. Wearing gloves when working with hand tools can protect you from cuts, abrasions, and blisters. But don't use them if they keep you from grasping a tool firmly. Gloves can also help to cushion you from vibration when using jackhammers and other impact tools. But they should not be worn when using most power tools. A glove can get snagged on a blade or bit and draw your hand into the cutting edge. Long hair, loose clothing, watches, and jewelry can also get caught in a tool's moving parts. So always pull your hair back, roll up your sleeves, and remove loose items before beginning to work.
It's important that your tools fit both you and the job that you are doing. Many of today's tools have fiberglass handles or soft rubber grips that absorb impact and reduce fatigue.
One of the most dangerous things that you can do is to use a tool in a way that was not intended. Most hand tools are made for a specific purpose. Don't try and cut corners by using a screwdriver as a chisel, a wrench as a hammer, or a knife as a screwdriver. You're likely to severely damage the tool, the material that you are working on, and your hand. Never modify a tool either. Tricks such as getting more leverage out of a wrench by slipping a piece of pipe over the handle can result in a serious injury. The size of the tool is also important. For instance, hitting a large nail with a small hammer could result in a glancing blow, while it's easy to miss the mark if you use a large hammer to drive home a small finishing nail. Either way, you are likely to receive a painful hand or finger injury. Many power tools are extremely versatile, but what may be safe operation for one tool could cause another to injure you. Look at the owner's manuals for your tools and always follow the manufacturer's instructions.
You probably use electric tools every day, but did you know that 1 out of every 5 construction deaths is due to electrocution? Many of these fatal accidents are caused by tools that are not properly grounded.
Grounding is necessary with most electric tools because they have metal housings or other parts that can conduct electricity to your hand. The easiest way to get shocked is to cut or damage your tool's power cord. To prevent this, always be mindful of where the power cord is and cut away from it. Power cords can be fragile. Don't use them as a spare handle. Disconnect tools by firmly holding the plug. Never tug on the cord. And avoid overstretching or pulling on them. You could easily expose the wires and create a shocking situation.
One of the most dangerous things that can happen while using power tools is to have them kick back at you.
Kickbacks occur when a tool's blade or bit binds up in the material that is being cut, and the force of the motor drives the tool towards you. This can result in a serious laceration, even an amputation. You shouldn't have to exert much pressure on a tool to make it work. If it feels like a tool is fighting you, the cutting edge may be getting dull. Use carbide-tipped blades and bits whenever possible. They hold their edge longer. If the blade is sharp, the problem may be with the material. For instance, wood can be difficult to cut if it has big knots or it is wet, so choose your stock carefully. Other things that you should do to prevent kickbacks include using the correct blade or bit for the job that you are doing. Make sure that material doesn't shift by clamping it down or having someone help you to hold it in place. Allowing tools to come up to full speed before trying to make a cut. Keeping both hands on tools for better control. And changing directions gradually so that you don't jam the blade or bit into the material. Always unplug your tools before changing blades or bits and allow some time for them to cool. Using a tool creates a lot of friction, which can cause blades and bits to become extremely hot. Be careful that you don't cut your hands. Wear gloves whenever possible. When discarding blades, wrap them in cardboard or several layers of newspaper so that people handling the trash won't cut themselves either. Once you have finished with a tool, clean it and put it away to ensure that it's ready for the next time that you need it.
Having a healthy respect for your tools and following some basic safety rules can help you to avoid injury. Let's review.
Know the hazards that each tool presents and how to combat them. Keep your tools clean and in peak condition. Use the correct tool for the job. Don't use cutting tools that have dull bits or blades. Use tools that fit you ergonomically. Inspect your work area for hazards and use tools that are the safest for the situation. And always wear the appropriate personal protective equipment for the work that you are doing.
By taking the time to keep your tools properly maintained and using them correctly, you can get your job done faster and more safely.
Hello and welcome to Tech Ed LLC. Today we're going to be taking a look at the bandsaw and a little tour of the parts that are in there and how to safely use it. This would be the front side of where you'd be standing when you're using the saw. On the back side you can see that there's typically a motor. Sometimes it sits on top of the base, other times it's actually in the base and may have a closed cabinet. The motor is attached to the wheel on the inside. This one is belt driven, as most of them are, and that bottom wheel is what turns the blade, which is a band. It's a large band, almost like a rubber band, and it makes a continuous loop all the way around. The bandsaw is very unique because of the blade that it has. It's continuously cutting, kind of like a circular blade does, but with a bandsaw, it's always cutting in one direction, it's always pushing down, and there's no upward force, and that's what makes a circular saw dangerous and a table saw dangerous, where you don't have that with a bandsaw because the blade is always moving in the downward direction where you're cutting. We'll see that in a little bit. We're going to take this blade and put it in place, put it inside the saw. And when you do that, it has to be properly aligned. This would be done by your instructor. The band has to be properly tensioned, and that's what the top knob is. And as you turn that top knob clockwise, it should start to stretch that band out, and that will make it very taut, and that's what makes it able to cut in a straight line. You also have another knob there in the middle, and that one is for the alignment on the wheels on the inside. Here you have the guides for the blade. Now these are bearings, and these bearings are very important because this back bearing here prevents the blade from moving backwards. So you'll start to hear this whine a little bit as you're pushing onto it. And then these two on the sides are preventing the blade from turning left or right. On certain models you might not have bearings, you might have these wear blocks that go in there. There is another set of bearings underneath the table as well that does the same thing. So to properly set these up, you back off all the bearings, and then you bring up your bearings so they're just about a 32nd of an inch away from the blade, and that way when it tries to go some way, it hits the bearing, but when it's under normal running conditions, it actually doesn't touch the bearings. There is a knob in the center here on the side, and what this does is it allows the guard to go up and down, because you want this guard to be about an 1/8 to 1/4 of an inch above the work. It does two things for you. It guards your hands from touching the blade. The closer it is to the workpiece, the safer it is. It also gets those guide bearings close to the work and gives you more control over the blade. You have a lot of benefits from putting that guard close to your work. Sometimes it does make it a little harder to see, but the benefits outweigh the cons. This one here, we've applied a fence to the table. This would be used for ripping a piece of wood. You have to be careful in using a fence with a bandsaw because bandsaw blades tend to track to the left or to the right, and you have to actually align the fence with the tracking of the blade. So it's not like a table saw. That can be sometimes kind of difficult. But you can see with the fence cut, as the board is guided by the fence, the teeth of the saw continuously cut down. There's virtually no chance of a kickback when you're dealing with a bandsaw, and that's what makes it so safe. The part that's dangerous is you have a blade that's exposed and it cuts really fast. But a bandsaw is a very nice machine for doing this type of stuff. Here's another view on the back side of how that board was being fed through the bandsaw using a fence. The next we're going to look at is a miter. Now this has a miter gauge going across, and again the gauge itself is here, and right now it's set up at a 90-degree angle, so as you push the gauge, it pushes the block of wood this way and pushes it through the saw. You can also adjust this angle here on a miter gauge and set it up for whatever angle it is that you need. Here's an example of that. This has been twisted a little bit. The gauge still goes straight, but the board is now held at an angle, so this cut would be at an angle. The bandsaw also is able to do a lot of curved cuts, which is nice. The trick about curved cuts is you have to make sure that your pivot point is the blade. You can't try to push the block of wood left or right to make it go left or right. You have to pivot at this point. If you do push left or right, then you're going to damage the blade because you're probably going to push it really hard against one of those bearings or one of the wear blocks. The danger zone in a bandsaw is marked in red. You never want to have your fingers in this area. As long as you stay out of that area, you should be fine. Well, let's zoom in here a little bit more. You can see where the blade is. Always keep your blade about a 1/4 of an inch above, 1/8 to 1/4, whatever is recommended with your machine. And as always, you should read and follow your owner's manual, as each machine is unique, and also your instructor's instructions on how to use this machine. In this part of the bandsaw safety video, we'll be taking a look at different ways to use the bandsaw and also some other safety rules that you should follow. First one is to always ask permission from your instructor before using the bandsaw. Accidents can happen quickly on this machine, so it's always wise to make sure that your instructor knows that you're using it. Make sure you follow the instructor's directions and rules when they're giving their safety lessons in class. This is a good place to learn how to properly use your particular machine that you have in your classroom. Some instructors will have you read and understand parts of the owner's manual. Make sure you do this, and if you don't, make sure you ask for understanding. As always, wear your safety glasses while using any machines in the shop. Long hair should be tied back. You should remove or secure loose clothing, such as rolling up your sleeves, removing scarves, or the strings that hang down from hoodies, things like that. The guard on the bandsaw needs to be set at the proper height. Normally this would be about 1/4 of an inch above the top surface of the board that you're cutting. Make sure you have room for the board to slide freely underneath the guard, but don't leave too much room. The more blade that's exposed here, the more likely an accident can occur. So lower the blade so it's about 1/4 of an inch above the workpiece. You should always keep your fingers out of the danger zone. There's a danger zone that's above the saw, which is pretty apparent, but there's another one which is below the saw, which a lot of people don't realize is there. So make sure you never reach underneath the table as well. When cutting curved surfaces, tight corners tend to need to have relief cuts put into place. The relief cut allows the blade to turn a little bit sharper than it could and if you didn't have that cut there. This takes a little bit of practice, so you can always ask your instructor if you need a relief cut in the curve that you're cutting. You should always wait until the blade comes to a complete stop before reaching in. The wheels of the bandsaw hold a lot of momentum, and it's one of the machines that actually does coast for quite a while. Some machines actually have foot brakes on them that you can press on, and actually it'll stop the wheel so it doesn't take as long to stop. Another danger is people don't realize that that blade is still moving and never walk away from the machine until that blade has stopped either, because the next person that comes up right behind you may think that it stopped, but it's actually still coasting. So make sure that you stay there until that blade stops or before you reach in. Always report accidents and malfunctions to your teacher. If you do have an accident, make sure that your instructor knows. And if there's something wrong with the machine, or you feel like the blade is dull or something's not working right, you should tell your instructor. This could prevent an accident from happening to somebody else. And if you don't know what you're doing, play it safe. It's that simple. Just make sure that you ask somebody or your instructor for help. See how many safety violations you can find in this image. I think the most obvious one was the thumb is in line with the blade. When the blade is getting ready to exit the material, it is always important not to have any body parts in line with the blade. A board can lunge forward a little bit because that when the blade exits the wood, there's less resistance there, so never be in line with the blade. Another one is the safety glasses are on the face because they're sitting there on the table. Sleeves aren't pulled up, they should have been rolled up to the elbow. The guard was not lowered into the correct position. The hand is within the danger zone. And there is scrap material laying on the table. Good job if you found all these safety violations. Here's a list of the rules that we just went over. Your instructor may want you to copy these down into your notebook.
On the heels of the videos I do, one of the questions I've received a lot is, why is it that when I use the miter saw, let me move that little guy, I make the cut, let the saw stop, then come up, And in fact, that little guy is the answer right there. As a general practice, when you're using the miter saw, what you want to do is go all the way through your work, release the trigger, let the brake take effect and stop the blade, then come back up. Now, the problem if you don't is that when you have small offcuts like this, or even more so like that little guy, the blade can grab those small pieces and they ricochet around the shop a few times before they come to a stop. Now, when I've taught this in classes and I say that exact thing, the parts bounce around the shop a little bit. About half the people in class are standing there nodding their heads, and maybe you're doing the same thing because they've experienced this. So again, your protocol here, let me get a fresh leg because you got to have a leg to stand on. What you want to watch for, I'm going to start the saw all the way through the cut, release the trigger, wait, then come back up. I think another byproduct of following this approach is better cut quality on the end grain of our material. Because what we're doing is running the saw, going through the wood, making a cut. Because we stop and let the blade stop before we come back up, we're not pulling those teeth back across the cut surface. So make sure you follow this protocol. It's going to be safer, keep those little pieces from bouncing around your shop, and I think you'll see better cuts on the end grain. That means less sanding, and you got to love that. Josh, how long have you been dipping your toe in the woodworking water now?
Less than 2 years.
And you've come to me a couple times with some questions about woodworking in general. Specifically, lately we were talking about some questions you have about the table saw. So we're just going to kind of freewheel here, and you're going to hear them as I hear them. So lay it on me. What do you want to know?
Well, as I've been working more, doing more woodworking, there's some tools that I have become more comfortable with, and the table saw is a tool I just cannot get comfortable with, probably because I haven't had formal training. But just some of the basic safety procedures I should be aware of: where to stand, how high should the blade be, when to use a push stick. So let's start there.
All right, well let's start a step before that, which would be, if we're going to mess with the saw, unplug the saw. And no matter how safe you think it is that it's plugged in but it's shut off or whatever, that ain't the deal. So you always want to make sure it's unplugged like this one is right now. Now, the blade height is a great question. This part of the blade, you know what those are called, those valleys between the teeth?
No.
All right, it's a goofy name. I wouldn't expect you to know it because it's bizarre. These are called the gullets of the saw blade. And anything that's got teeth has gullets between the teeth. Bandsaw blade, handsaw, whatever it is. So when you're setting this blade height, what you want to do is set the bottom of the gullet even with the top of your material. And that gets the blade in a position where it's safe to use. It's not too high, not too low. It's a great place, a great thing to keep in mind for your blade height. Okay. Body position, you are in perfectly the wrong spot right now. I'm actually okay. So the way to look at this would be, when you stand here, you're directly in the line of kickback from the table saw blade. So kickback is when the blade has the opportunity to grab a chunk of wood and throw it out pretty violently. The rim speed, the teeth on a table saw blade are going about 150 miles an hour. So I'm not trying to scare you off, but I'm just trying to give you the reality that if those teeth grab a chunk of wood and throw it back, it comes back really fast. Right. So what I tell my students is, use these lines in the table, which are your miter gauge slots, as a guide of where you should not be. So the danger zone is any place in between these two lines. And you're right-handed or left-handed?
Right-handed.
Okay, so for the most part, for you, you're going to be to the left of the blade, to the left of this slot. If you're doing a rip cut with the fence in place, you'll be pushing with your right hand and just kind of turning your hips to keep yourself away from the line of cut, the kickback line of the saw blade. Okay. The other thing I've seen students do in class is, when they're tentative about a table saw, they tend to stand back away from it, which is natural. But what happens as you're making a cut is you run out of arm. And you don't want to get to where you can't reach far enough to finish the cut, or you're leaning a lot to finish the cut. So this way you can locate yourself so that your hip is right up against the beam of that saw. You're as close as you can get, and that way you can push stuff all the way out onto the outfeed table. The push stick, the famous Russian hockey player, push stick. Anytime your cut is 3 inches or less on a rip, you have to use a push stick. If it's over 3 inches and you still want to use a push stick, that's fine. But 3 inches or less, you got to use it. And that happens all the time. Face frame rails and stiles, door rails and stiles, a lot of aprons for tables, a lot of narrow stuff out there.
Right.
Push pad, this is going to come into play. So as far as what you need in your safety kit, when we do dados or rabbets on the table saw and provide a whole down pressure, you want to do that with a push pad instead of the push stick, because then you can get more on the surface of the piece. And the big thing here is you got to have a guard in place. I can't say enough about this. If the guard that's with your saw is a lousy one, if it doesn't work for you, there are aftermarket guards out there that you can look at. The guard brings a lot of things to the table saw table. There's a splitter here. The splitter infills in what's the kerf of the cut. So as we start to push a piece of wood through, the blade makes a path, and that's called the kerf, where the wood has come away. The kerf goes on either side of the splitter. Have you seen it where wood like expands or contracts as it exits the blade? So the deal there is the wood wasn't dried correctly, and this happens fairly frequently. And if it wasn't dried correctly and it starts to pinch in behind the saw blade because the splitter's not there, it can climb up on the back of the blade. It's going to lift it off the table saw table, and that's a huge cause of kickback. Right. So the splitter acts as an infill for that. Then additionally, the splitter also includes these pawls. They're very sharp here on the bottom. They're anti-kickback pawls. So what happens is they're a one-way gate. The wood can push through them, but because of the sharp fingers on there, it can't come back. And that does a lot to help reduce or prevent kickback. And then, of course, the basket over the top of the whole thing is what's going to really help keep you out of harm's way with that table saw blade. How'd I do?
Good.
Anything else I can ease your mind a little bit with table saw?
No, I think this is a good start. I'm sure I'll have more questions as I go along.
All right. Well, hopefully with this information we'll help Josh make the cut and answer his safety questions about the table saw.
Hello and welcome to TechEd LLC. Today we're going to be taking a close look at the drill press. The drill press is one of the most common machines found in workshops and technology classrooms because of its easy use, its ability to drill holes in a very accurate location, as well as depth and angle. The table is able to ride up and down, and it is able to do that by using this system over here. This particular model has a rack and pinion system which allows the user to crank this handle here around in the clockwise direction, would smoothly raise the table. In the counterclockwise direction, it would lower the table. But before they are able to do that, they would need to unlock the table, which this mechanism is usually found on the other side of the drill press. This tightens up and it squeezes this collar here, and when it's tightened, it squeezes around the column so the table can't move. So it's always important to make sure that the table itself is locked down before you use the drill press. It is important to make sure that you do have a rack and pinion style setup before you loosen this table lock, because if you don't and you loosen this whole table can go quickly sliding down. And if you don't have a good hold on it, you could drop it, you could injure yourself, or even break the machine. On top of the column is the head. The head has all the other parts attached to it. You have a motor that's in the back, and that motor is attached to a pulley underneath this cover here. The pulley has different grooves in it, and there is an opposite pulley on the other side which is attached to the spindle which runs through here. The belt can be placed in a couple different positions. Every drill press is a little different. This particular model has 3 grooves in the pulleys. Right now it's set on the middle one, which would be for average speed. But say you wanted to drill a lot of lightweight thin material with a small bit. You could speed up your bit by taking the belt and lowering it down to the lower setting. This would increase the spindle speed. To do that, you would loosen this lever here, which would release the tension of the motor, slide your belts down, and then tighten this back up. Or maybe you're drilling something like metal, which is very hard. Or you have a big bit attached to the drill press and it needs to go slow as well. So now you'd need to put the belt all the way in the upper position, and this would help slow down the bit speed. And again, make sure this is tight. Most likely in your tech class or shop class you won't be adjusting the speed, but if you have to, always ask your instructor to give you some help. The next part we're looking at is the spindle wheel. That's these three levers here. This is what you pull down on to lower the spindle in your bit into the wood. It's pretty easy to use. It is spring loaded, which helps the drill come back up when you're done. So when you're done with your cut, make sure you don't let go of that lever, or the whole thing can kind of snap back up, and again, you might injure yourself or the machine doing so. Some spindles have a lock right here, and this is called a depth stop. So if you want to only drill so far down into a hole, into a piece, that would be how you do that, is set the depth of that bit. Other drill presses have things on the other side which would help set that depth. Again, your instructor will help you set up your drill press the way that you need it. Next, we'll take a look at the spindle. Now the spindle is not this part down here. This is called the chuck. The spindle runs from here. It's the spinning shaft that goes all the way up and connects to that pulley up in the top of the head. At the bottom of the spindle is the chuck. Now the chuck is a pretty neat little gizmo that helps grab onto round items, your bits that you'd be putting in there, and it automatically centers them because there's three teeth or jaws that are down here that automatically center it so it doesn't wobble around. You do need to tighten these down when you do that, and you'll find that there is a hole which the chuck key can be inserted in, and you'll see that there's some teeth that are up here, a gear system that'll help you tighten this up. Again, your instructor can help you with your particular model on this. In part 2 of this video, we'll be going over how to use a drill press safely. The first thing you should do is get permission to use a drill press before going ahead and turning it on. Always ask your instructor if it is the right time for you to use it and if it is set up correctly for you to use. You should also follow the instructor's directions and rules. Make sure that you listen carefully during safety lessons that they'll be giving you during class. Each of these lessons has specific details on exactly what it is that you're doing with a drill press. Every drill press is different, so your instructor really knows what it is that they're doing and what it is that you should be doing, so pay careful attention during those lessons. Some instructors will have you read parts of the owner's manual. If so, you should read and understand those. Others may just be going over the points that you need to know. You should wear your safety glasses while using the drill press and also while using other machines in the shop. This is a very important step that a lot of people sometimes forget to do, but you only get one set of eyes, so make sure you always have your safety glasses on. Remember to remove the chuck key while using the drill press. Sometimes they can shoot out of the chuck as it's spinning, and this can cause serious injury. So never leave it in there. If you're using it, always hold on to it and never let go of it until you remove it from the chuck. Secure the workpiece. It's very important that you clamp down the workpiece or have it in a jig or a fixture. This will ensure that the workpiece stays stable and doesn't get loose and possibly spin around. If this does happen, always remember to turn the machine off. Do not reach in and try to grab the piece. This can result in a bad injury. You should always tie back long hair. Long hair has the possibility of getting wrapped up inside the chuck, which is spinning at a high rate of speed. This can cause severe injury. Remember to secure loose clothing. Baggy clothes, bracelets, watches, strings from hoodies are all dangerous while using the drill press. They can get wound up inside that spindle or chuck just like long hair can. So make sure that you keep them back. Also remember to pull up your sleeves so they're about at your elbow. Use proper speed and feed. This varies with what it is that you're drilling. A big bit can drill a large hole, but it needs to be drilling slower than a smaller bit. Smaller bits can spin a little bit quicker depending on what material it is you're drilling. If you're drilling wood, the bit speed can be a little bit higher than if you're drilling a hard material like metal. There's several factors that determine the speed of the bit. The feed is how fast it is you're plunging into the material. Again, if you're drilling wood or a soft material, your feed speed can be a little bit faster. Your feed when dealing with metal has to be slow, as the bit will have a hard time getting through all that material. So watch your instructor carefully during the lessons that they give you in class about how fast that feed should be. You should keep clear of moving parts. Rule of thumb, you don't want to be near the spinning bit. Keep your fingers back as far as possible. You should wait until the machine comes to a complete stop. You simply just shut it off, take the extra second or two until it comes to a stop before removing the workpiece or unclamping it from the jig fixture or from the table. If you do have an accident, report it to your instructor immediately. There could be a couple things that went wrong. Maybe you goofed up and you hurt yourself, that's one thing. But maybe there's something wrong with the machine or the jig fixture or the clamp that holds the piece in place. Your instructor should know about this so they can take action to prevent it from happening to somebody else. And last, if you don't know what you're doing, don't do it. If you were absent during the lesson in class, you should ask your instructor before going ahead and doing it. So if you're in doubt, don't do it. Play it safe. Here is an overview of the drill press safety rules that we just went over. Your instructor may ask you to copy these down into your notebook.